So hi children, in the previous video we discussed Pythagorean triplet no. So in this video we are going to discuss about that square root and its properties. What about that? Square root and its properties. So first we will discuss about that square root. First we will discuss about that square root. So what about that square root? Before going to that square root, what about the square? Square means a number which can be expressed as the product of two equal factors, as the product of two equal natural numbers, or we will call them as the factors no. So we can say that one as a number which can be expressed as the product of two equal factors, then that number is called square of the given number. Square of that given number. So here what about that square root? So here a number which can be expressed, a number which can be expressed as the product of two equal factors, then each factor is called square root of the given number. Square root of the given number. Okay, so what about the definition? Once again say that a number which can be expressed as the product of two equal factors, then each factor is called the square root of the given number. Each factor means here both factors also same only no. Each factor means I am saying two equal factors. One we are saying means another one also same only no. That's why I am saying that each factor is called square root of the given number. Okay. So here what about that? For example, take that 4. Okay. 4 we can express it as the product of 2 into 2. 2 into 2. We can say that 2 is the square root of 4. Here we can say that 2 is the square root of 4. Here each factor I am saying 2 is the square root of 4, and here if you consider this 2, this is also a square root of 4 only no. Okay, so that's why here if you express the given number as the form of the product of two equal factors, then each factor or one of the equal factor we can say that is the square root of that given number. So here what is the square root of 4 means 2. Now here what is the square root of 9? Yes, 9 we can write it as 3 into 3 no. So 3 is the square root of 9. Okay, 25. So 5 into 5. 5 is the square root of 25. Okay, 25 is the square of 3. Sorry, 25 is the square of 5, and here 5 is the square root of 25. Okay, so in that vice versa. Here 3 is that square root of 9. 9 is the square of 3. 9 is the square of 3. Okay, did you understand that? What about the square root? Okay, so see here what is the symbol which we can use for that square root. So this is the symbol. Okay, we will call that one as a radicand. What is the symbol? Radicand symbol. Okay, we will discuss that one in third concept. Okay, so here how to find the square root of that number? So here I told you that 4 no. So 4 we can express it as 2 into 2. Okay, so we can write this one as the square root of 4. Now I want to find that square root of 4. So we can write this one as 2 into 2. We can write this one as 2 square. Yes or no? 2 into 2 we can express it as 2 square only no. So we have to apply that square root. Okay, now here square and root gets cancelled. Its value is equals to 2. That's why we are saying that 2 is the square root of 4. 2 is the square root of 4. Why madam here square root and square gets cancelled? What is the reason? Yes, here what about that square root? Here square root means like this only we are writing. We are writing this symbol means here we have that square. The value is square. Nothing is there means we have to take that one as a square no here at the place of n. That's why we will call this one as that a square root. Okay. For example, here 3 is there means that is the cube root. 4 is there means a fourth root. Like this there means this is cube root. Okay. Like this there means this is a fourth root. Okay. Like this n symbol is there means that is nth root. Okay, we will call like that. So here this value is equals to 2 no here n is equals to 2, so that's why we will call this symbol as a square root. Okay, so if you convert this one as the power, okay, then here square root of like this there no square root of 4, we can write this one as a 2 square whole square. So we can convert this one as 2 square. This square root become as 1 by 2. That square root become as 1 by 2. Here cube root become as, for example, here x is there. So x power 1 by 3. Here also some y is there. So y power 1 by 4. Here nth root is there, no nth root of a. So this is a power 1 by n. Okay, that is the meaning of that square root. Like this roots we can convert like this in this form. Okay, that's why here square root become as in that power form, that is 1 by 2. So here 2 and 2 gets cancelled, no? Okay, that's why here directly we can cancel that square and root. Okay, without doing this process, simply wherever we can say that square and square root, just those two gets cancelled. So what is the reason? Everyone is saying that just square and square root cancel, but what is the reason? This is the reason. Okay, that square root is after converting it to that power, we will get that one as 1 by 2. So now this is in the form of a power m whole power n. We will learn that one in exponents concept. Okay, in mathematics every concept is interlinked concept. Okay, so here 2 and 2 gets cancelled, so we will get this one as 2 as that square root of 4. Is it clear? Now we will discuss about that some properties of square roots. Okay, so here what about the first property, that is number of digits in its square root, number of digits in its square root. So how we can say that? Okay, so for example here 16 there, what is that? 16. So how many digits are there in its square? How many digits are there in its square? So how we can say that 16 16s 256 is that value. Okay, here we are having 3 digits. Here we are having 2 digits. But my question is, how many digits are there in the square of that 16? In square of 16. Okay, how many digits are there? Here 3 digits, here we are saying 2. Okay, then how we can find that? Yes, in that square, how many digits are there? In that square we are having 3 digits, no? If that square is having that odd number of digits, if the square is having odd number of digits, then we have to add plus 1 by 2. Add plus 1 by 2. Then here we are getting that 4 by 2, which is equals to 2. So in that square root we are having 2 digits only, no? In that square root we are having 2 digits or not? Okay, for example, here 16 is the square, 16 is the square of 4. 16 is the square of 4, which means 4 4s 16 only, no? Okay, now here this square is having 2 digits. If that square of square is having that 2 digits, then its square root is having how many digits? How we can say that? Yes, here the square number is having how many digits? 2 digits. So that is having even number of digits or odd number of digits? Even number of digits only, no? So even number of digits there means here the formula is 2 by 2, which is equals to 1. So the square root is having that only 1 digit. So what is that formula here? If you take this number as n, if you take that square numbers as 1, if the number square number is having that even number of digits, then number of digits there in its square root is n by 2. In its square root is n by 2. Okay, so here Here what is that formula? If that square of a number is having that odd number of digits, then the formula is n plus 1 by 2. Then number of digits there in its square is n plus 1 by 2. Okay. So what is that condition? If n is odd, then what is the condition? N plus 1 by 2 digits there in its square. Digits there in its square root. Okay, so what about n here? Here n is the number of digits in a square. Here n is number of digits in a square of a given number. Okay, so here what about that n is even? What is the condition? That is n by 2. Okay, now my question is, if that square of a number is having that 8 digits, square of the number is having 8 digits, then number of digits there in its square root. Number of digits there in its square root. So here n by 2 is equals to what I am saying? N is equals to square now. So I am saying that 8 digited number. Square is having that 8 digits. So number of digits there in its square root. That is 8 by 2 is equals to 4. 8 by 2 is equals to 4. Okay. Or else in that reverse also we can say that if that square root of a number is containing 4 digits. Square root of a number containing 4 digits, then its square is having how many digits? Then its square is having how many digits means here I am saying my question is number of digits in a square root. Actually this is a square root formula only, no? Number of digits to find in that square root. So here number of digits in a square root is 4. Now number of digits there in that square of a number, its converse I am asking. So here we need to find that n value. So n is equals to 4 into 2 is equals to 8. So that is that square, in that square we are having 8 digits, then its square root is having that 4 digits. So in the two cases also question will come. Okay, in any form they will ask that question. Just you have to see that that number of digits given in that square or square root. Okay, that is the difference. If number of digits in the square they given means n value they given. Number of digits in the square root they given means here n by 2 or n plus 1 by 2 something they given. Just you have to see that. Okay. Next one. And we know that a square number never ends in 2, 3, 7, 8. Yes or no? If that number is having that 2, 3, 7, 8 in its ones place, then we can say that those numbers are not perfect squares. Okay. Now what about that square roots? How we can say that? If that square root is having that 2, then what is its units place digit in a square? Okay, that one we will discuss that. If a square ends in 1, if a square ends in 1, then its a square root ends in, okay, in that square I am saying that if that 2, 3, 7, 8 any one of the digit is there means that is not a perfect square. What are that leftover numbers? Those are 1, 4, 5, 6, okay, and here 9. If that any square number is consisting 1, 4, 5, 6, 9 means that is a perfect squares only. Those all are perfect squares, we can say that. All are not. If that is a perfect square, then that can be ends with either 1, 4, 5, 6, 9. If that is a perfect square, it should not ends in 2, 3, 7, 8. That is the difference. Already we discussed that differences in that previous video. If anybody missed that video means once go to that video and check that. Okay. So here if a square ends in 1, so what is the meaning of that one? Here for example 81 is there. 81. So here 81. This is a square of that some number. Square of that some number. We don't know that what is the number. Okay, this is the square of that some number. This is ending with 1. This is ending with 1. Now here its square root is ending with which number they are asking. Okay, so here two possibilities are there. What are the two possibilities? That is, one is 1 or 9. 1 or 9. Why? Because 1 into 1 is equals to, we will get it as 1 as it's in units place, or if you take that 9, 9 into 9 is equals to 9 9s 81. So here also in its units place we can observe that 1. Yes or no? So here what is that point? If a square ends in 1, then its a square root ends in either 1 or 9. Two possibilities are there. Okay, let us see that next point. If a square ends in, here that should not be ends in 2, no, 3 also not possible, so should be ends with 4. Okay, 2 and 3 completed, 1 completed, next 2, 3 should not have in that square number, so next we will go for that 4, then its square root ends in, then its square root ends in, here how many possibilities are there? Here also two possibilities we can check. What is that? That is 2 into 2 is equals to 4, we can observe that. 12 into 12 is equals to 144. Okay, so 22 into 22 is equals to something you will get, right? Okay, so every number ends with a 4 only in this case. Next, another one is 8 8s is 64. Here also units place we can observe that 4. So how many possibilities are there here? Either the square root is having that either 2 or 8. 2 or 8. Okay, next one. So next 4 completed. Next 5. If the square ends in 5, then the square root ends in. Then the square root ends in. How many possibilities are there? Only one possibility is there. That is only 5. 5 into 5 is equals to 25. 25 5 is 125. 125 5 is 625. Okay, whatever it may be, that number should be ends with 5. Should be ends with 5. Okay, next one 6. So children, see here, if the square of a number ends in 6, then its square root ends in either, here how many possibilities are there here to get that 6 in its units place? Yes, we have the two possibilities. One is 4, that is 4 into 4 is equals to 16, and here 6 into 6 is equals to 36. Okay, so here 6 is there, here also 6 is there, so we have the two possibilities, no? So that's why its square root is ending with either 6 or 4. 4 or 6. Okay, so what is that? If the square of a number ends in 6, then its square root ends in either 4 or 6. So what is the next number? If the square of a number 6 completed, so 6 after, the square of a number never ends in 7. We know that. 8 also not possible. Next 9. So here, if the square of a number ends in, if a square of a number ends in 9, then its square root ends in either, here also two possibilities are there. What are those? Here, if the square of a number ends in 9, then the possibilities are 3. Why? Because the 3 into 3 is equals to 9. Another possibility is 7. So 7 into 7 is equals to 49. So here also the number is ending with 9 only, no? Okay, that's why here how many possibilities are there? Two possibilities are there. So what are those? Either 3 or 7. Either 3 or 7. Is it clear? So where we can use that these all properties means in that division method we can see, and in the same way in that estimation methods, in that competitive examinations, for example, if you don't have that time, that much of time is not there, okay, by using that division method, which methods we will discuss later, okay, if you forgot that method, okay, then how to find that the square root of the given number? If you learn these properties, easily you can estimate that one. For example, here one of the question is there, that is 729. What is the square root of 729? You don't know that what is the square root, okay, but you know that the properties. What is that? Here the square of the number is ending with 9. Square of the number is ending with 9. So here you can observe that the options A, B, C, D options there, no, just go to that options A, B, C, D for, and you know that the properties also, a square number never ends in 2, 3, 7, 8. So eliminate that some options, okay. For example, two options, one of the option is ending with 2, so that is not a perfect square, so leave that. Okay, here we are discussing about that square roots now. So how many possibilities are there here? 9 is there, means the possibilities 3 and 7. 3 and 7. So which numbers are having that 3 and 7 in its units place? Okay, then check that numbers. Another number is there, for example, that is ending with 2. Another number is ending with some 4. That number is ending with 2 means in its square number it will end with 4. We know that. One of the number is ending with some 3. Then its square is ending with 9. Okay, we know that the properties now. So by using these properties we can estimate that one. So after that you eliminated 2 options. Next we have only 2 options. Just check that. For example, that is 13 into 13. So check that one, 13 into 13 is equals to, we will get that 729 or not. Okay, next 27 into 27. So here also possibility is there, 7 and 7, we will get that 9 in its units place. Okay, we can check for the 27 and 27 also. Okay, so by using these properties, just we can estimate that one. If you forgot that methods, or in that examination if you don't have the time, then you can use these properties also. Is it clear? Yes. here square root of mn, square root of mn, we can write this one as square root of m into square root of n, square root of m into square root of n. Okay, we can write like this. So one of the example, for example, what is the square root of 25? So we can write this one as square root of 5 into 5. So this is in the form of m into n. So we can write this one as square root of 5 into square root of 5 we can write. Okay, or its converse also we can write. And another one, square root of m by n, square root of m by n. We can write this one as square root of m by square root of n, square root of m by square root of n. Okay, like this also we can write it. Okay, so these all are the properties what we discussed up to now. These all are the properties. So in that next video we will discuss that square roots, how to find the square roots of the given number and how to find the square roots of its decimal numbers. Okay, we will discuss that one later. Okay, in that next video. Okay.